Let's see if I can. Oh, good. All righty. You know, science is a funny thing. Sometimes it's too difficult or too expensive to get to study the real thing. So you end up studying analogies. You end up studying analogies instead, things that you think resemble the real thing, and see if you can draw reasonable conclusions about the real thing from that. Now, I got lots of air miles saved up, and the trouble is they're no good to get me to Mars. But this past spring, they did get me to a beach in Brittany in western France. And what I saw there made me think of Mars. In short, I saw what I think are analogues of surface processes that have sculpted the Martian surface in its early geological history. And that's what I want to talk about tonight. Now, much like cigarette packages and movies with adult content, I have to warn you about analogues. As a professional geologist, I've done quite a bit of laboratory modeling on how rocks might behave when they get squished, for example, by colliding continents. They're great fun. That's to say, these analog models. They're great fun, and they do stimulate the thought processes. But you must never lose track of the fact that there's a huge difference between reproducing the same end result and simulating the natural processes that actually got you there in nature. Technically, this is known as the problem of causality. Just because you turned A into B doesn't guarantee that you did it the way that nature did when you do it in the laboratory. So it's really important that you keep this in mind while we talk about models and analogues of what may or may not really occur in nature. Next one, please, Chris. Okay, having taken care of my insurance policy, let's cut to the chase. Here's a typical image of one kind of Martian topography, canyons. Most planetary geologists would suggest that they were carved by water. Next one, please, Chris. And here's another image of the same phenomenon, and it points out part of the problem with this hypothesis. Both the main canyon, this thing here, and the lateral alcoves coming off the side are blind. They simply stop at steep cliffs. This raises a critical question. If they were carved by water, where did the water come from? On Earth, your average valley is carved by river systems that have typical branching patterns as tributary valleys coalesce progressively to feed into the main valley, but not here. Next one, please, Chris. The previous images showed you the upstream end of typical Martian canyons. This is the downstream end looking back upstream. This is where whatever was eroded to form the canyon has spilled out of the canyon mouth to form what's technically referred to as an outwash plain. That's this stuff here coming out of the canyon. Now, keep this blind canyon and outwash plain topography in mind, because we're going to see quite a bit of it in the next few slides. Next one, please, Chris. And this is where we're going to see it. This is a very ordinary sandy beach in Brittany, western France, where I spent quite a bit of time this past spring. It's nothing special. Many of you have probably seen beaches like this wherever you've been spending holiday time. But I wonder if you took a good look at those sandy beaches. So let's take a good look at this one. First, you notice how flat it is. There really isn't much of a slope. And secondly, this is important, notice how wet it is. Tens of meters from the sea, and it's still soaking wet. This is going to turn out to be very important in my Martian analog proposal. Next one, please, Chris. So here I am, I'm standing close to the surf zone, my back is to the sea, I'm looking inland towards the sand dunes that form relatively high ground compared to the beach, and there are two things that I want you to notice. Firstly, notice the dry sand. That's this stuff here, the really nice clear stuff there. Oops, sorry. That's this here. There we go. That's the dunes, and then it's this here is the dry sand. And the more extensive wet sand in the foreground here. What does this tell us? Next one, please, Chris. Well, this wet sand tells us that the sand beneath the surface is waterlogged. and that the upper limit of the waterlogged sand intersects the surface slope of the beach a long way inland from the sea. Here's the surface slope of the beach. The sea is out here. This is where the dunes would be. This is the dry sand near the dunes. And this dotted line here is the top of the waterlogged sand, and it intersects here with the surface, so this would all be the wet sand. And this is what's called the upper limit of the water table. Next one, please, Chris. The second thing that I want you to note. Yep, good. The second thing that I want you to note is the streakiness in the wet sand. You can see it best in the foreground here, but this streakiness goes right the way back up to the limit of the wet sand. If we walk inland towards the dry sand, but still within the wet sand, we can see that the streakiness of the wet sand has an inland limit above which the sand is perfectly featureless. So we'll see that in just a minute when I think on the next slide. Next one, please, Chris. There we go. Here's the featureless sand. The dry sand would be up here, and then here's the streakiness. So here we are within about a meter of where the water table comes to the surface of the beach, and where surface water starts to flow down the very shallow slope of the beach with just enough energy to start to erode very shallow channels in the sand. And you can see these very shallow channels here. Next one, please, Chris. Now, it may be just coincidence, but here on the left, here, is a very similar channel pattern on the Martian surface that appears to start from nowhere, just like the beach features. Nothing, and then streakiness. Nothing, and then streakiness in channels. Note, of course, that the Martian pattern is at the scale of kilometers to tens of kilometers, in contrast to the beach channels, which are at the scale of centimeters. Next one, please, Chris. Okay, back to the beach. Unlike rivers and streams, these channels are everywhere. Instead of the water localizing in narrow valleys, it flows like a huge sheet uniformly about a few millimeters deep. While it doesn't concentrate in valleys, some of these anastomosing channels are longer and more continuous than others. Watch this one here, for example, and another one here, and then there's another one here, and there's one over here doing the same kind of thing. So what? Why get excited about this? Next one, please, Chris. This is why. On the left is a Martian landscape, kilometers across, with what I think is an analogous pattern of channels to those which we've seen already in the beach sand. Here, even the long channels here, the same as this long channel here. Very different scale. Very different scale. Next one, please, Chris. And if we look more closely at the beach sand, we can see that the surface water has carved anastomosing channels that isolate elliptical islands, like this one here, or this one here, or even this one here. And those elliptical islands, they contain older, even finer scale channels which are preserved internally. You can see them here, you can see them there. Next one, please, Chris. And if we get still closer, we can see that the surface water in the anastomosing channels, and you can actually see the water is actually flowing in those channels as I take the photographs. It's actually managed to carve cliffs, see them here, here, which stand several millimeters high. If the width of these channels on this beach was really kilometers across, as it would be in the Martian example, these vertical cliffs would be the equivalent of tens to hundreds of meters in height. Next one, please, Chris. So here we are, we're still at the beach. As the erosion in the channels proceeds, it progressively isolates elliptical islands of high-standing sand, and you can see them nicely defined here, even better than in the previous slide. Next one, please. And here, on the left, is a Martian example.
Aren't your labels reversed here? Sorry, Simon, but aren't your labels?
Nope. Sorry, pardon, you're right. This one here, I've got my labels in the wrong place. This is Mars, that's the beach.
They're not on Mars. Who was there? Kilroy.
Chris, have you been playing with this, Chris? All right, take me for a mug. Hang on a minute. You wait. There's yet you will see some footprints in a minute. All right. I guess I asked for that one, didn't I? Huh? Alrighty, whereabouts am I here? Okay, there we go. Oh, the hell with it, my labels were in the right place.
There's only certain speakers we can do this to yet.
Okay, all right, here we go. So, as I suggest, on the left is a Martian example of something that looks very similar to our beach channels. And I'm going to suggest that the two are perhaps analogous. Next one, please. Here's a second example of what I would suggest is the same analogy. Now, there are so many examples I could show, but these two will suffice to get the point across here. Next one, please, Chris. Now, how do we know that these channels and islands are really erosional? This is key. Well, on the beach, we can actually see the relics of older beach ripples. See these ripples here? We can actually see them within the islands and trace them, in fact, from one sand island to the next. The ripples have clearly been truncated as the shape of the islands was determined by erosion, by flowing surface water that is still flowing in these channels, by the way, as I'm taking these pictures. Next one, please, Chris. Let me check, see what's been done to my image here. Okay, fine. And here on the left is a Martian analog with internal ridges that can be traced from one topographic island to the next. These internal ridges here within the islands can be traced from one island to the next. Remember, in all the cases that I'm showing you here, the Martian examples are very different in scale from the beach pictures. Kilometers to tens of kilometers on the one hand, centimeters to maybe a half a meter on the other. Next one, please, Chris. So let's go to just downslope from where the water table intersects the beach surface, and the erosional features first begin to form. I'm checking my image. Now, apart from the dog paw prints, there are paw prints in this one. They're supposed to be there. Definitely not Martian analogs, at least not yet. What do we see? I see a trough right there. I see a trough with a blind upper end that appears to be the source of a very different sand. This sand is quite granular here compared with the sand at the very surface. Very different kind of sand, a sand that forms what looks like a downstream outwash plane and had to be derived from underground. It's not this sand, it's another layer of sand underneath that's been washed out here. Next one, please, Chris. This was not a random one-off feature. These blind troughs appear to be characteristic of the beach close to the point where the erosional features first appear. No erosional features, they begin to appear, and the troughs begin to appear immediately. Next one, please. And here you can start to see how they are indeed blind. They're like blind canyons, and they're bounded by lateral cliffs. You can see them quite nicely picked out by the shadow here. Every one of them has these nice high-standing cliffs. Next one, please, Chris. These are what geomorphologists, or you might call them physical geographers, refer to as box canyons. And in this particular case, you can clearly see that the canyon floor has a few millimeters of water flowing in it. This one here very nicely, and you can see the water flowing through there too. While the plateau into which the canyon is being carved, that's this thing up here, including the broken glass, is dry. Clearly the water in the canyon is coming out of the ground. It's groundwater, and it represents the level of the water table at the moment I took the photograph. Next one, please, Chris. Here you can see how the flow of the groundwater onto the canyon floor at the base of the canyon cliffs is leading to collapse of the canyon walls. You can see it nicely here. You can see it even more nicely here. This is not erosion by surface water, as in a river valley. This is what geomorphologists refer to as sapping. It's as the water comes out of the ground, it weakens the cliff and the cliff collapses. Next one, please, Chris. Well, here at a very different scale, potentially is a potential Martian analog of the beach box canyons. This is probably several tens of kilometers across at the very least. This image that I found from NASA didn't have a scale on it. As for the beach examples, the canyon is blind, and there are no tributaries which would have fed surface water into the canyon to account for the erosional topography. Next one, please, Chris. Here's another Martian example with a somewhat different morphology. This one's nice and spoon-shaped. And next one, please, Chris. And yet another example, just to press home the point that these blind canyons are very common on the Martian surface. Here's the top of the blind canyon here, and the canyon would go out this way. Next one, please, Chris. We've skipped one. Have we? Oh, no, no, no. Next one, please, Chris. There. Hang on a sec. Let me just check where that image is definitely out of sequence. Okay, we'll pass on this one. Next one. There we go. Okay, I'm good. Okay, so back to the beach, where I came across this beautiful example of multiple blind box canyons, which were feeding into, which represent tributaries to this major channel here. Again, you see the major channel is full of water. Next one, please. And I'd like to suggest that this example over here is an analogous feature on Mars at the scale of multiple kilometers. Compare this, any one of these, with this feeding into the channel.
You see the flow lines in that one.
Yes, yes, indeed. Yes, you can see the flow lines here, and in fact, when you're looking down into through the water, you can see the flow lines in the beach example too. Next one, please, Chris. There we go. Okay, so these blind canyons on the beach look like the larger examples on Mars, but what does that tell us about whether the processes that formed them were similar? Well, here, back at the beach, plus paw prints and footprints, there are footprints, I believe they're mine. You can see the blind box canyon feeding into an outwash plain. There's the blind box canyon feeding into that outwash plain there. And at the mouth of the canyon, you can see what appear to be blocks of the canyon wall, right there, that have slumped onto the outwash plain. Next one, please, Chris. Okay, I'm just checking that one there is definitely out of sequence. Okay, what we'll do, Chris, we'll jump back to that one. Move forward one. There we go. Actually, no, we've got a number of them are out of sequence on this one. Move forward one more, just so I can see what's going on here. Okay, that's this one. Move back. Okay, let's bring this. Move back one. There we go. Okay, so this is a close-up example of that slumping occurring. Let's move to the next one. Alrighty, we're talking about the process here of forming these. So these blind box canyons forming by this sapping process feed into these long curved channels. Next one. And I think that this here on the left is a Martian equivalent of this kind of long channel. And I believe if we go to the next slide, this was simply to show you that not only is it my interpretation that this slumping here is due to the sapping, I actually came across this process occurring. This slump here actually occurred as I was stepping across the channel. Next one, please. And here, this Martian example here, this is indeed in the long curved channel. This is indeed, I think, the same kind of slumping we're seeing in this long curved channel here on the Martian surface. Let's see how we're doing. Next one, please, Chris. Okay. Yeah, these have come out of sequence here, but that's okay. And here's yet another example of that slumping. You can see the rubble here at the base of the steep cliff, and this fan here. So, yes, we'll work with that. Next one, please. Good. Okay, we're back in sequence here. So back to the beach once more. As I've already mentioned, the blind box canyons commonly feed into outwash plains. And where several canyons are closely spaced, those outwash plains can be quite extensive. And in fact, they can be quite impressive. Let's go to the next one. Here's what we were just looking at in the last slide, but we're looking upstream now towards the box canyons. And you'll notice how the broad curvilinear channels filled with shallow water separating the large elliptical islands with steeply eroded cliffs. You'll notice the islands and you'll notice the cliffs and the streakiness here in the larger curved channels on the floors. Next one, please. I think that is directly analogous. that previous beach example is a direct analog for this Martian case, which is hundreds of kilometers across, where broad curvilinear channels spill out of the heavily cratered Martian highlands onto the relatively smooth northern plains. The northern plains are here to the north, which is in the lower part of the image, and this is the heavily cratered terrain area to the south. Next one, please, Chris.
Process to give the appearance that there's water on Mars?
No, that's the image straight off of the NASA website. Whether they've played with it to give that image, impression, I don't know. I would hope not, because
the increased reflectiveness.
I know it really looks as though there's water in there. I've got to tell you that when you actually see this on the web, there is no indication in the text that that's what has actually been done. And in fact, I'm looking at this right now down here. That actually is not a NASA image. That's actually an image which is, you're probably right, it has actually been treated.
Is that near the polar cap?
No. This is probably very close to the eastern end of the Great Martian Valley, Valles Marineris. Next one, please, Chris. Okay, so while we're at it, let's compare this iconic, well-known iconic image of the erosional islands on Mars with features of that French beach. You can see the beach up here and the famous image here. And the
erosional islands similar to these in the Ottawa River, just a bit downstream of downtown. I forget the name of them. There's these sort of little almond-shaped islands that are...
Yes, but the thing is that they are associated with primarily with channeled flowing water in a river system.
Okay.
You're talking about Kettle Island?
Yes.
Yeah.
Next one, please, Chris. And here again, a similar kind of thing, the iconic Martian image, which you can compare with what we see on the beach. Now, they may not be identical in every way, but I think you get the point. The processes we see on the beach make us think about how similar features may have formed on Mars. Next one, please, Chris. Remember this Martian image that I showed near the beginning of the talk? Well, how do you think it compares with the image of what I would suggest is an analogous location with respect to the box canyons on the beach, looking back up towards the box canyons, and here looking into the main canyon system? Next slide, please. So here's the last look at the beach, looking towards the sea and the surf zone. And the take-home message from this photo is that the outwash plains with their flowing water and the active erosion of the cliffs at the upstream ends of the box canyons on the beach have nothing to do with wave and surf activity in the ocean itself. Everything we've looked at here is related to the release of groundwater and its arrival at the surface of the beach, and I would suggest the surface of Mars. The important point here is that when we're talking analogs, the important thing is once you've got the groundwater in the sand, the analog model begins to run. I'm not suggesting for a minute that a Martian ocean put groundwater into the ground of Mars. What the water is doing there is a different kettle of fish altogether, different set of processes altogether. Now, next one, please, Chris. I love analog modeling. It's really very exciting. However, you must not get carried away. Analogies between models and reality do not automatically mean that the models accurately simulate natural processes that led to what we see, for example, on the surface of Mars today. Philosophically, this is the problem of causality, where there are lots of possible ways of getting to an end result, but which one represents reality? Just because I can show you analogs of Mars on a beach doesn't mean I've proven anything. Let's look very briefly at just two flaws, two errors, if you will, in my analogy. First, if you look at a real Martian canyon from far enough away, it looks very smooth. Next one, please, Chris. But if you get inside them at high resolution, there's a roughness in the beach models simply do not reproduce. Secondly, even if you accept that the general geometry and relative dimensions of the beach and the Martian box canyons are similar, there's a major scaling error in the analogies that I've drawn for you here. If you scale the canyons, channels, and cliffs on the beach up to the scale of the real features on Mars, our beach sand grains should represent boulders the size of houses and larger. And this is clearly not what we observe on Mars. So if for this reason alone, you should be somewhat wary of taking my presentation too literally. However, the beauty and the purpose of analog modeling is that it enables us to envisage possibilities that may not otherwise have occurred to us, and it enables us to push our critical evaluation of what we're looking at, those ideas, to much further forward. Last slide, please, Chris. So let me close by asking and answering the following question. Do I think that the beach examples are reasonable analogues of the kinds of processes that have occurred in the distant geological history of Mars? Yes. Do they answer all of our questions? Unlikely. Do they point us in the right direction? Absolutely. Thanks for listening, and a happy year of the solar system to you.
Very nice, Simon. Thank you.
Did we have some questions?
Oh, only momentarily. We are over 10, but we'll have a couple. Okay.
What's your theory on where the water came from? Could there have been a large watery comet impact event that delivered the water, and then because of it being a smaller planet, it then evaporated off into space, leaving those channels in the runoff from the event?
No, you don't need it. The bottom line is we know that Mars in its early history, prior to 3.8 billion years ago, still had a magnetic field. That magnetic field would have protected its atmosphere. Its atmosphere would then have protected any water on the surface. And there's a lot of evidence that around, in the early history of Mars, there most certainly was water. There was most certainly was also glaciation. Thick glaciers are moved over Mars, and we can see them preserved. The chances are that what actually happened here is that as Mars began losing its water, it would have lost it in two directions. As it lost its magnetic field and lost its atmosphere, the water would have then disappeared off the top of the atmosphere without protection from the solar wind. The other thing is that water, as on Earth, would actually sink into the ground. And we're all, as Canadians, aware of permafrost. The most recent results from orbiting probes around Mars tell us that there is, even today, there is permafrost in the ground, and it is hundreds of meters in thickness, potentially up to a kilometer or so. All it takes, and this is what people are thinking about, is volcanic activity within the Martian crust, which then introduces local heat sources, melts the water, and that's how you produce your groundwater.
So Simon, are we really talking about oceans?
Are we talking about
Oceans? Are we talking about oceans?
Yes, I think the evidence is stacked up really nicely, and I gave a talk on this last year. I think they really are managing to show that the southern limit of the northern plains, which is the flat, younger surface of Mars, that really does look as though it is the floor of an ocean.
Well, the floor of our oceans here on Earth resemble what you're showing us here tonight.
No, actually, the floors of our oceans don't. There are erosional canyons. There's no doubt about it in the edges of the continental shelf, but there are no continental shelves that we can see that exist on Mars, because the floor of the ocean on Mars is very, very different geologically to the floor of the oceans on the Earth.